9.3, we're going to continue work with testing two population means for equality. The difference is, in this section, we're going to assume that our populations are dependent, that our samples are dependent, that something about one sample might affect something about the other sample. So we're going to say that we have dependent samples. That is somehow one might influence the other one. Now, another way to think of this is we have paired data. That your data come in pairs, and those pairs have to be assumed to be normally distributed, or you have to have a large enough n. So normally distributed differences, or more than 30 pairs of data. Okay. Now, there's a little bit of notation that we're going to have to kind of overcome here at the start. So I'll give you a chance to catch this up and then talk about some of that notation, because the book and I are a little different in our notations, and I don't want you to get in trouble when you go home and you see a mu sub d and you don't understand what that is. Let's take a look at this first one. So listed below are the number of words spoken in a day by each member of 8 different randomly selected couples. Complete parts A and B below. Use a 1% significance level to test the claim that among couples, males speak fewer words than females. So, in terms of the original claim, can anyone suggest what that original claim is? What I write there? We can use mu sub m and mu sub f if you like. You can use mu sub 1 or mu sub 2. What's the original claim look like in terms of symbols? Oh, well done. Who got that? Was it Joyce? Oh, Royale. Thank you so much. Yeah. Mu sub m is less than mu sub f. Now, where is that going to go? Is it going to be part of our null or alternative hypothesis? It has to be part of the alternative. So that means our null hypothesis is going to look like this. Well, I'm going to write down the alternative first. Mu sub m is less than mu sub f. So the opposite of that, and of course you've got to include the possibility of equality, is greater than or equal to mu sub f. Now, we're going to play around with this the same way we did in section 9.2. I'm going to subtract mu sub f from both sides and get another possibility here. Another way to write this equivalently would be mu sub m minus mu sub f. Can anyone fill in the rest? What would it be? Greater than or equal to 0. And likewise, mu sub a is going to be mu sub m minus mu sub f is less than 0. By the way, quick question for you. Left tail, right tail, or two-tail test? Left tail. This is pointing to the left. All right. Now, the book doesn't use this, neither does the homework system, MyStatLab. They're just going to call this a difference, and they're going to call this mu sub d. So when you put this into StatDisk, or not to StatDisk, but to MyStatLab, your claim, your null and alternative hypothesis are going to have to look like this. HO and HA. So you're going to have mu sub d is greater than or equal to 0, and mu sub d is less than 0. So that's what you're going to have to do in MyStatLab. Now for me, And when you're doing an exam, you could use either of these, any of these really. So you've got 1, 2, or 3 possibilities there. I'm not really picky as to which one you want to use. You know, whichever one works for you, that's fine for me. But do you understand that this notation is something that my stat lab uses? Okay, so let's pick it up here with this example A. So the first step in this is going to be, you know, mu sub O, or excuse me, let's see, we'll do mu sub D is greater than or equal to 0, mu sub D is less than 0. You could use one of these other two as well. That's fine. StatDisk seems to subtract the first population minus the second one. Just FYI. Use a 1% significance level. That's telling me alpha is 0.01. Okay, looking good there. What's the third step, generally speaking, in our hypothesis test? What do we do for step 3? Yeah, input the data. And for that, you can use the link that you found in D2L. Grab some data here. So that link is here. And that's 9.3. Yeah, there we go. Actually, I think I want to use this one, 9.3. Copy that data, paste it into StatDisk. So if you click in StatDisk online, it should take you back to the original data editor. Clear out the stuff that may be there. Paste in your stuff. Looking good. Where should I go in terms of doing the analysis? That's a good place to start, analysis, and then take a guess from there. Hypothesis testing. Yeah, mean matched pairs. We no longer have independent samples. There's something that's related. When couples marry, can you really say that they're independent? Probably not. I don't know. All right, so let's choose that one. Mean matched pairs. Looking good. Let's see. What alternative hypothesis should I use? 1, 2, or 3? 3 is looking good. Mean differences. We're going to do that at the 1% significance level. Let's put in columns 1 and 2. It's going to subtract them in that order. There we go. So our alternative hypothesis is that mu sub D is less than 0. So that's a left-tail test. But what information am I looking for here? P-value. So our p-value in this case is 0.39, 0.329. Really, I could have stopped at the first decimal point. I don't think I really need much more information than that. What conclusion am I going to get regarding our null and alternative hypothesis? What am I going to do here, step 5? I heard a mixture of fail to reject and reject. Which one is it? Fail to reject. Good. Fail to reject. Your p-value is bigger than alpha by a lot. Fail to reject H naught. Now our original claim, was our original claim in HO or HA? Original claim is not going to be in the null hypothesis because it doesn't include the possibility of equality, right? All right. I heard some HOs, so I wasn't saying you said it.
Only 2 people said anything. We both said HA.
All right. So I need to get my hearing checked then. Whatever. And don't say I'm old. I'm going to lower that grade. All right. In any case, let's take a look at this. And let's pair it up with this right here. Wording your hypothesis conclusion. Choose which one of these four you're liking. Which ones looks good? A, B, C, or D? Amelia, what are you liking on this one? D? Okay. Our original claim did not contain the possibility of equality, so looking good there. Did we reject H naught? No, didn't look good there, or looking good there. So yeah, D is looking good. So there's not sufficient sample evidence to support the claim that. So let's write that down. Is not sufficient sample evidence to support the claim that. All right, so that part was easy. But what should we not be supporting? What should I write there? Yeah. You can look right back here at the actual statement of the problem and just take it right there. That amongst couples, males speak fewer words than females. That among couples, males speak fewer words than females. Nice. Nice. Looking good there. How are you on that first one? Doing okay? Thumbs up? Hopefully you catch a groove for a little while in this course, because a lot of these things, even though they're different tests, it's the same kind of steps. And I do that intentionally. I want you to get comfortable with these same 6 steps. Let's move on down to example B. Researchers collected data on the number of hospital admissions resulting from motor vehicle crashes, and the results are given below. For Fridays on the 6th of the month and Fridays on the following 13th of the same month. Used a 5% significance level to test a claim that when the 13th day of the month falls on a Friday, the number of hospital admissions from motor vehicle crashes is not affected, or are not affected. I like is not affected better, but whatever. In any case, let's regard these as our H1, or our, mu1 and mu2. So Friday the 6th, that'll be our mu1. And Friday the 13th, that'll be our mu2. So we got mu1 and mu2. All right, looking good on that. Now there is kind of a little problem with this. With such a small data set, we can't necessarily really apply any testing to decide if it's normally distributed or not. Certainly we don't have more than 30 pieces of data, so we might be on a little bit of shaky ground doing this hypothesis test. I'm acknowledging that up front because I still want to go through with the test, but yeah, you're going to have to assume that this data comes from normally distributed populations. I'm not so sure that that's true, but I do want to go through with the rest of the work here. Now, what is it the claim that we're testing? Let's kind of highlight that here real quick. The number of hospital admissions from motor vehicle crashes is not affected. So it doesn't matter if it's the 6th or the 13th. Number of hospital admissions is unaffected. So what's that mean in terms of mu sub 1 and mu sub 2 as far as our original claim is concerned? If it's unaffected. So we don't know what mu 1 is, but what are they trying to get at here? Does anyone know? What's the mystique about Friday the 13th? Pretty close. Yeah, it's supposed to be unlucky, all right? Bad things are supposed to happen on Friday the 13th, kind of like a black cat crossing your path or walking underneath a ladder or things like that, superstitions like that. So it's trying to prove or disprove this kind of thing. Now, if the number of crashes is unaffected from Friday the 6th to Friday the 13th, what would you expect about these two means? Be equal, less than, greater than, not equal? Should be equal. If it's unaffected, then both of them will be the same. It doesn't matter if it's Friday the 6th or Friday the 13th. This is unaffected. So from there, we can state our null and alternative hypothesis. Let's do that to finish this one up. Example B. So our original claim was that mu 1 equals mu 2. Let's put that in step 1. Mu 1 equals mu 2. Mu 1's not equal to mu 2. The alternative. Nice. Marvin, what's step 2 going to be for us?
Significance level.
All right. All right. Significance level. Thank you very much. 0.05. Nice. Niana, what's step 3, typically speaking, for us? What do we do there? Yeah, input the data. Okay, so let's input that data, and I do believe that's some of the data I have for you on the Google link. So let's see, that's here, down here. If you're watching this later, I think this QR code gets you to that Google link. So let's copy this data, paste it into StatDisk. So I'll clear out the stuff that's already here. Click StatDisk Online, clear, yes I'm sure. Paste in. Let's go to analysis, hypothesis testing, mean matched pairs. Which alternative hypothesis do I want? 1, 2, or 3? 1. Looking good there. Significance level, 0.05. Let's set up columns 1 and 2. And it's telling us that mu sub d is somewhere between here. But let's take a look at what we need here from our hypothesis test. What should I highlight, or what's important that I get here? Our p-value. P-value in this case is 0.035. That's good enough. Joyce, what should I do about our null hypothesis? What's our decision in step 5 here? Remember, you got your alpha here, your p-value here. If the p-value is low, h naught must go. Good, so you're going to reject h naught. This is smaller than this. That wasn't the case up here. This was bigger than this, so we failed to reject. Down here, the p-value is smaller than alpha, so reject h naught. Let's set up our alternative, or set up our conclusion in words. Which conclusion are we going to use here? A, B, C, or D? Let's take a second and think about that, and then maybe check it with a neighbor. Which one you liking? Like an A? All right, I think I like that one too. Let's take a look here. Our original claim contains the possibility of equality. Yes. And we rejected it. Yes again. So you're going straight across the top in terms of your decision tree here. And it's yes. There is sufficient evidence to warrant the rejection of the claim that. So let's see if we can't get a little bit past this. There is sufficient evidence to warrant rejection of the claim and what should I put in for the final wording here? What works for us down the bottom here? Yeah, you can get it directly from the problem itself. When the 13th day of a month falls on a Friday, the number of hospital admissions for motor vehicle crashes is not affected. So maybe I'll extend this a little bit further. But there, you don't have to really think too deeply about it. Just try and give me something that's a little bit more than something generic that you could write for everything. This should be something that pertains to this problem. That when the 13th day of a month falls on a Friday, the numbers of admissions from motor vehicle crashes, or number of hospital admissions from motor vehicle crashes are not affected. Number of hospital admissions from motor vehicle crashes okay, good. Crashes is unaffected. Nice. Nice. Okay. We're going to do a little follow-up with that. But before I do the follow-up, are we okay with our conclusion here in terms of words and rejecting H naught? All right. I'm hoping that you start to catch a little bit of a groove on this kind of stuff. Let's follow it up with a little reminder of something that we spent time with in section 9.2. Let's go back to the output here. What is the confidence interval saying? Is the confidence interval saying that you should reject H naught or fail to reject H naught? What do you think, Garrett? Is that saying the same thing as our hypothesis test? All right, good. Why? Why is it saying the same thing as our hypothesis test? So our confidence interval, let me write that down. or 95% CI is between negative 6.0 mu sub d less than negative 0.3. So, okay. 0.32, I'll say. Why is this saying the same thing as our confidence or our hypothesis test?
Because there's no zero in it, they're both negative.
Yeah. This confidence interval does not contain zero. If your confidence interval doesn't contain zero, the one possibility that we're excluding is that, the difference in these two things is zero. I should probably look here. Keep in mind, we're going to test mu sub d equals mu sub 1 minus mu sub 2. That's how we're going to find these things. But if these two things are equal, then that difference is zero. This confidence interval says there's at least a third of a crash difference, if not 6 crashes difference between Friday the 6th and Friday the 13th, meaning it could be a lot more crashes depending on where the true parameter difference is in this interval. But it is saying that there is a difference. So this is consistent with our conclusion from the null hypothesis, that we rejected it. Okay, we're going to jump down to example D for our last one. So one of the possibilities for you, if you like to partake in social media and you track yourself, and things like that, is if you're an exerciser, there's an app called Strava that allows you to post your workouts and keeps track of your statistics and things like that. And kind of like Facebook, they have their analog to likes, and that analog is kudos. So one particular athlete noticed that the athlete was getting much more kudos, or it seemed like you're getting more kudos for biking than swimming. So the reason this is dependent is because it's the same athlete on successive days of the week. A Tuesday then Wednesday, or Wednesday then Thursday. So your data is paired. It's paired within that individual. And we want to examine, do you get the same number of likes for swimming as you do biking? Okay. So in this case, we're going to test a claim. Test the claim that mu sub s is less than mu sub b. As on average, this enthusiast gets less kudos for swimming than biking. Okay. What level do we want to test it at? Well, it looks like the 5% level. So alpha equals 0.05. Let's run through this. So this is example D. Now you could set something up like mu sub s is less than mu sub b, and the alternative would be greater than or equal to mu sub b. But if you're going to use StatDisk, then you might want to get comfortable with the notation there, and that is, this is going to be mu sub s minus mu sub b is greater than or equal to 0, or mu sub s minus mu sub b is less than 0. But neither of those is exactly StatDisk or my StatLab. StatDisk is going to write that as what? What's it going to write instead of mu sub s, or mu sub 1 minus mu sub 2, or mu sub s minus mu sub b? Mu sub d is greater than or equal to 0, and mu sub d is less than 0. So that's step 1. Step 2, you're not going to have to decide on alpha for yourself, typically speaking. If I forget it, then choose either 0.01 or 0.05, and I'll grade you accordingly. Just as long as you run your hypothesis test correctly. Step 3, let's input the data. All right, so we'll go back here to example D, grab that data. If you're curious what StatDis is doing, it's taking the difference between these two and running a one population t-test on this. So it's just saying, okay, I'm going to subtract these and treat it as if it's a one population t-test. So back to chapter 8 kind of stuff. All right. Then you can kind of see the numbers here. The mean for swimming days is about 7.1. The mean for cycling days is about 10.3. So, it looks like there's a difference. Let's find out. Let's copy this data set, except for the text at the top part of it. Clear out this stuff here. Paste that in. Analysis, hypothesis testing, mean matched pairs, 5% significance level. There's one thing I got to take care of. Or alternative hypothesis, 1, 2, or 3. What's looking good there? Liv? What are we looking at? 1, 2, or 3 for the alternative hypothesis. One more glance at this part right here. All right, looking at 3, like that one, 3. Data sets for 1 and 2 respectively. And bam. Nice. What information do I need from this page? Angie? The p-value, good. So the p-value in this case is 0.00035. And let me stick with you one more time, Angie. Am I going to fail to reject H0 or reject H0? Reject H0, good. Your p-value is less than alpha, so we're going to reject. So looking good there. Reject H0. Now our confidence interval doesn't exactly match our value of alpha, does it? Why not? What would I complain about if you gave me this confidence interval? Remember, your significance level and your confidence level should add up to what? 1. All right, I'd like to see that. If you're going to talk about the confidence level, you should be talking about it relative to the appropriate significance level. So there was a couple fixes I could do for that. What was one of them? What's the easiest one? Nice. Change the alternative hypothesis to a not equals. That should give me my 95% confidence interval. What's the important thing that you see from the 95% confidence interval?
No, 0.
It does not contain 0. If it doesn't contain 0, is that consistent with the null hypothesis or the alternative hypothesis? It's going to be consistent with the alternative hypothesis. Basically what we're saying is that if this difference doesn't contain 0, this isn't a possibility, nor is this, because that would have to equal 0 in order for this to be true or to be a possibility. So yeah, our decision here to reject H0 is consistent with what we have here. It doesn't have the possibility of 0, so we would reject H0. Colin? As long as the confidence interval does not contain 0, you would still probably be rejecting H0. Yeah. So, yeah, if this is set up the right way, I'm trying to think. That's a good question. Let me flip that around. If I change the order of these things, so there you go. There's a confidence interval that doesn't contain 0, but it would take a little bit of work to convince yourself of this, but it is testing the same thing. I'd have to set this up a different way, but I think I should still get the same p-value. All right, so if I twisted things around, again, my confidence interval doesn't contain 0. Actually, that's the wrong confidence interval. But they're both positive. And again, it doesn't contain 0, so it would lead you to rejecting. All right, appreciate that. Good question, good question. Last but not least, let's see, our original claim was in the alternative hypothesis. So this would be our original claim. Which one would we use? A, B, C, or D here to state that? Original claim. Does our original claim contain the possibility of equality? No. Did we reject? Yes. So the sample data support the claim that more kudos are given for biking than swimming. Yeah. Sounds good. So sample data support the claim that more kudos are given for biking than swimming. Nice. Anything else on this one? Christine?
Is paired data always dependent?
Is what?
Is paired data always dependent?
Yes. That's the nature of dependent data, is that they're paired, that one is related to the other one somehow, so that the results aren't independent. Like, you know, I could have tested you on your math knowledge coming in and leaving out of this class. But those are going to be related because it's still you that's being tested. And if you knew a lot coming in, you're probably going to know a lot coming out. Whereas, you know, you could have somebody else in, you know, different situation, but how much they go out with is going to be related to how much they come in with. So they are related. Those data come in pairs.
So if the Strava example were like everybody's results instead of one guy, then
Ah.
it would be independent?
Great question. Yeah. So if this was data for like just everybody, if I could convince Strava to give me all the data for kudos for swimming and kudos for biking, then it'd probably be independent. I mean, without really actually getting that data, but it seems to be leading towards an independent test. This is dependent because it's the same individual getting these kudos from one day to the next in the same week. So that's why they can be paired up like that. So great question. Great question. All right. Let's hold things here. Let's see. I think that's it for this section. So let me stop it here.